Hello everyone. We are continuing with the workflows update of the WAN 2.1 long-length videos workflow. Now, I've worked on some updates last weekend and yesterday, and these examples here are for image to video, which is an easier way to handle, less conditioning and some of that stuff. For example, we have long-length videos like this. We can handle them with an easier, less bulky workflow to run with less complicated stuff. Because right now, I've found out that we can use loop conditions. And thank you for the inspiration from a few people here. Now, first of all, in the workflow that I posted last time, which is this version, it's limited in the number of lengths due to the parts that have been defined, from the start to the end of this workflow where we got 6 parts of the sampling steps, cut it in size, and then process each 81 frames or 129 frames to do that. And it still has limitations because the length is fixed only by how many samplings we have in all those groups here. On the weekend, one of the supporters added more logic to this workflow, as you can see. Thank you for the inspiration, JSN. The workflow that he did in this version is a lot more complex. As you zoom in here, you can see all the if condition statements and all the things. It's good if you have a computer background. If you're like a 3D artist or just doing artistic stuff, you'll hate it, that it require you to think in a logical way. All the math formulas put in between, you'll like it because these conditions are really good to handle how many lengths of video and by how many samplers we need to use in order to generate the whole video length section by section and pass it through from the start to the end of part 6 of this workflow. But still, there's a limitation of the video length because we are still limited to 6 samplers here to run however long the video needs to be. So let's say we have a 1-minute video, and that won't be able to handle it here because we only have 6 samplers, 6 parts of the control net handling in this logic. Although all this, if statement true and false, is very good. He defined really in detail all the frame handling, how many frames need to be passed into the next sections in order to generate the video. And also there's a wildcard for random backgrounds as well in here that he did for the prompt, so it will remove the image backgrounds. Like, for example, I have this AI character here. It will remove the background and have a random background based on the wildcard that you input here. So I was trying to solve the problem, if there's any custom node or any way in logic to loop through the whole video length. So let's say I have this dance video. It's almost a minute long of this dance routine. How can we loop through it? And also, I have to thank Usako USA. He asked this question, which was very inspiring for implementing the for loop node here. So I was searching in ComfyUI because there should be something like this. When you type loop, there's all the supporting loops for how you can handle the logic in ComfyUI, where you can use the ComfyUI Easy Use Custom Nodes pack. It includes the for loop start and ending, as well as the while loop. So right here, we are using the for loop start, and you have the for loop end, where you have to indicate how many loops it will go through in this section. So let's say you have 3 in total. It will loop 3 times in between this data passing through in this section. While the while loop is all like how we studied in university and diploma computer science, where we are learning how to program in C and Java. This was the fundamental basic stuff when we were studying, so again, the while loop is using the value passing through each of these sections. So in between here, let's say I got the value 0, a better way to pass it again to the value 0. We will have the conditioning here. Let's say you have an if condition that has a Boolean true or false. So whether it is true or false, you can pass this to these conditions until the false becomes true, and it will end the while loop here. Because at the start of the while loop, we set it as true. So when everything coming into here is true, let's say I got a reroute of something and then another reroute and other conditions, maybe the data is something larger than 1, we will pass to true. Otherwise, if something keeps it at number 0, we will stay in false. Then once it is in false, it will stop this while loop, just like that. So the concept is all like what we used to do in the fundamentals of programming back then in the old days. So although this is really good, JSN has done a really great job, tremendous good job here, handling all the lab and stuff. And then since I got this feedback from Usako USA, yes, we should apply the loop for this workflow. Because the loop, Look at that compared with what we had previously, is to trim it down, slim down the workflow a lot without all the big-ass chunky workflow looping all along to the bottom. We need only one handling of the conditions in this group, which is I am currently using the for loop start and then the for loop at the end here. The only thing we are going to handle is the numbers of frames. So this is a very easy way to handle in this section the initial value 1. This is actually the image frames from the video generation. And after that, we are going to pass directly all the frames from the video into the video combined, which is a very straightforward way. And you don't have to handle multi-parts of groups here, or my previous examples where I used different parts of sections, and then, after all, you need to combine all these parts of videos to videos and sections to sections combined into one video combined. Right now, you don't need to do that. It's already handled and passed at the final result, and then you can use the video upscaler. Now, JSN has recommended using the tensor upscaling. This is a way faster upscaler and more practical, but it requires some installations for the tensors if you are running on an NVIDIA GPU. And then the other simple way that I usually use for image or video generation is upscale with the model. So this way is going to be easier. You don't have to install the tensors from NVIDIA. Either way works. So by that, I just bypass these two groups here. So you have the freedom to choose whichever method you want to run for the upscaling. But that doesn't matter. This is just a little small part of this workflow. The whole purpose of this workflow is handling the numbers of frames from your source video. So right here, as you can see, this video source, and then we can jump back to this section where I have a load video here, or the more beginner-friendly way, you can use load video by upload. Some people still ask me, why? What's the difference? There's no difference. It's just using the file path as input here. That's all it is. Both custom nodes work. So either way, it works. And it's just how it is to be putting that into the video. And then the image reference here is the same. Well, I still keep this flux context in case you want to restyle the first frames of your source reference video and then use that image as the new WAN-based control net first frame, or you have another entire new image. Just like in this example, I have my AI character here, and then I use that to process for the first frames as the reference video. So in the first part here, I'm using the reference image, passing it to the WAN video-based control reference, as well as using the DW pose here. Either way works. And then also, this one I did a little extra, and I just simplified how I did that for the image to video. So let's say I have 15 seconds length here. I set the total seconds that I want. If you guys have experience in FramePack, this is something similar that you can define the numbers of seconds in your input, and then it will loop through and generate each section by section, just like how it does in FramePack and here. Because of this logic, using the for loop, we can use it based on part 1 of the video and then just apply the same thing here. But it's more simplified because we don't need to handle the control net. As you can see, the empty space here was handling the control net like the video to video here. So in image to video, it's much easier than video to video since we are just handling the start image frames. We get that from the previous part 1 of the video, and then we start continuing our generations here, frame by frame, part by part, and then keep going. And the last part here, we are doing the same thing. Stitch it together with our generated video, and then pass it into value 1. And then this value 1 will keep looping on and on and on. In this section, if you have no computer background in programming or whatsoever related background, don't worry about that. This thing is already handled, and as you can see, it's the numbers of loops here already. Do the calculation. This is we need to loop this 4 times. So after the math of the total seconds, FPS, and then the length of these sections, it's already handled in the image for the image to video, how many times it needs to go through these sections. So this is how I just did this example, the similar one like this example as well. So like this one, it's the same start frames from here. And then, the character goes walking around like this, so much better. Right now, we have the WAN 2.1. Unlike before, we just had some other AI video models to handle the animations. So as you can see, 18 seconds, we are able to handle in image to video. And image to video is even further faster, less complex logic because we don't need to carry the control net. And we don't have to detect the indexing of your reference video. Therefore, it's faster. Each section of the video generation in the sampler is faster. For me, I was generating about 1 minute for each section in this sampling here. Let's try this again using the same image, and we will do another prompt. So in this process, it will be like this ongoing process right now, loading the tensor upscaler. But then, at the front here, it has a video combined here to show you the progress of how the videos are going to display each section. After the extensions of the video, it will show first here, and then it will go to another new sampling step to process another section of the video, and this is just basically a for loop for the whole thing to do, depending on how many numbers of seconds you want to define in your video. But one thing in this workflow is that this is handling up above the first part of the videos. That means that if you are setting your each chunk of numbers of frames to 81, and if your frames are 81, then that will be generating about 3 seconds for the video. So the total seconds should not be under that, no, 3 or 5 seconds. You want this to be longer than that setting in the total seconds here. So as an example, I did 15 seconds, and it looped going through here 4 times. And after the first part of the video generated, we get the last overlap frames and pass it to the long-length video generations. So I call this the looping gen, and that means it keeps looping until the total seconds finish. We stitch it together at the end of the end loop and then pass it to what we have here, showing us the result. So as you can see, it's able to do that. And even using the tensor upscale is even better because you can select like 2K, 4K, whichever resolution you want to play around with. Just like the preview, like this one, we have 15 seconds of the upscaled video. And then we are going back to the video-to-video method, which is a little more complex because we need to handle the control net here. But it's still just one more conditioning. After we combine everything, we pass it to the control videos in WAN 2.1 vase, and then we have the mask. This is also coming from the first and last frames here. This is just what it is for controlling the first and last frames. We use this method to generate the videos continually. The same logic applies to the for loop, and we stitch it together at the end of this part. We trim off the overlap frames since I defined it in here as well. Let's try another example which is using the video to video here. So I'm going to use another Korean K-pop dance video as an example, and then this is going to be in a fold of 500 frames, total of frames. Now, in video to video, it's a little different. We are not counting on the numbers of total seconds in the settings. It's based on the frame count from the load video here. It's more direct to do the numbers using the frame numbers counting here for how many loops that you are going to do. So the formula here is a little different compared to what I have for the image to video. But then it's the same logic. We go through the start of the for loop, we pass how many frames from the source video, as you can see right here, source video, and then we go to the frame count. We count that, we pass that frame count to the initial value too. That means we are going to handle how many values that we are going to use here as well. And then the value 1, which is the part 1 of the video because we need to get the list of videos that is actually generated for the output result. So we are using the part 1 of this video to extend how long that we are going to have. Although the math formula here is very simple, just plus and minus and then multiply and divide, all this basic logic stuff, but then you have to connect in the right positions in order to get these things done right. So this way, I should not be using the image preview. Instead, I am going to use the video combine as well. So you will have the progress showing how that is going to look like. We are going to pass this value 1 as well to the image combine. So this way, you will see the progress once it's generating loop by loop. You will see the new sections of how it looks like. And this is also stitching with the part 1 of the videos. So let's say after the 5 seconds of the first part 1 generation, it will start getting to this part 2. And then the part 1 here is the same as what I did last time in the previous version. From this long-length video generation, we are using all the same settings. And then I also simplified how that is going to use here. As you can see, it's more cleaned up, and as well as we don't need to use the overlap frames sections here. So I just put it in place so it's more clear for you to see the progress of this workflow, how it evolved, and then it starts to become more dynamically calculating how many frames that you need for the extension part of your video to video. So let's say I have 81 frames here defined it in the settings section, and then it will go through the first 3 seconds here in the part 1. And then let's say the other rest of the 10 seconds will be generating in the long length videos. So let's try this and we will see how that goes. Once I start running it, it's processing the numbers of frames in the low video path of this K-pop dance. And then it will start loading the sections of the models. And one more thing I have to mention, by the way, is that the models here, I have also modified them between the previous versions. As you can see, the previous versions, it's something like this where you have the models loader, everything connected like that, and then I tightened it up more using the LoRa control here. So whichever LoRa you need, you can find it here as well. And I have the GUF quantized model as well as the safe tensor loaded here. Then that is, so far, we have a more simplified way to run here as well. And there's an error here because the permission error is based on the path here that I need to define. So yeah, just be aware of that. If you are using the path defined here for the image, you must have to input an image path. Otherwise, the laziest way to do it is load image and connect it here. So let's say I have an image of what I need, and I will use that path for the image and run this again. And there, I have my image for the dancer, just for the demo purpose here. And then we are going to process in the first part of this sampling from this workflow. It will be processing the control net first. And once we have the control net, it is going to pass into loading the clip loader as well as the model VAE as well. And then we start, as you can see, start processing the WAN base to video node. It starts processing the K-sampler. And I'm going to pause in this part first until the loading the loop. I'm going to show this part how it is going to process in this section. So in this video example, as you can see, once it is on the progress of going through this loop condition, generating each section of the chunk, while we say here 81 frames per chunk, it will process each one here. It depends on what your hardware can handle and how it can handle. But so far, the logic of overall these generations of the frames in this workflow is also the same. And as you can see, after the VE decoding, it should be going back to our loop right here, so it shows how many times you need for the generations. Here, the counter is 6. So it will be going through 6 times of this loop for the sampling. And after the 5th one, just like what you just saw, the VE decode and going through all this stuff, it will be passing into here. It should have the full view of this video here, like this. And then, of course, you can enable one of the upscalers here to use for your video upscaling. This is very self-explanatory. For the groups, right-click and run it as always. Then you can use that. Otherwise, take it to never, then it is disabled the groups. And this is how we can use and be able to generate a pretty long length of videos. As you can see right here, I did in the progress 18 seconds of this video generated and the progress. Actually, I cannot say my progress is the standard time because a lot of differences depend on the computer hardware. It depends on how fast you can run. But 54 seconds this time to generate the 81 frames. So each of that is going to allocate my 96 gigabytes of VRAM, and then I allocate another 8 gigabytes plus in the RAM just to show how you can do in the multi-GPU nodes using the GGUF quantization. So because I set 8 VRAM allocations from my RAM, it is showing here, obviously from the CPU, allocating the 8 gigabytes of RAM plus that will be included in my CUDA to run this. So total, I have 103 gigabytes of VRAM, and let's check out the other rest of the progress. So I just wanted to do a proof of concept that this works. Using the vase and then low sampling steps you are setting in these setting groups here, I put all the lengths that the models that you need here as well. You can check it out. And also, we have, let's see the video output here. This time, I did the color match. So some people said that, oh, it will be having different color contrast, or the color will be oversaturated throughout the sampling. Yes, because there's some different samplings happening using the CosVid LoRa model and also included in the Fusion X model. But then, right now, it's soft. The problem is solved using the color match before it passed to the trim of the video to cut the overlap frames. Then it has pretty smooth right now. Doesn't have any flickering of the colorations or the different contrasts between each section, almost the closest color as you can possibly get right there. And that is how you can do it a lot slimmer after the optimizations of this workflow compared with what we were having. Did the long length of different parts like that? Well, this is for the different parts of the video sections with different sampling. It was, in the programming way, we call it hard coding, which for mostly the first versions and prototyping any software, we will do hard coding for demo purposes. And throughout that, it's key evolving. Just like in software, the workflow as well, we keep evolving and we do more dynamic conditioning for the logic here, and as well as if later on in this workflow or, this long length video series of this workflow. Because right now, I'm also including the image to video, as well as later, I will use video vase 1, 2.1 vase to have more different features of long video length as well. But then it's the same. We will apply the for loop logic. And maybe we will need to use the if conditions logic here to handle some of the frame numbers and play around with those math games here. Less, error that will be possibly caused to handle error conditions using the if conditions. Just like what JNS did in his modified version of the workflow, where he passed all the conditions of using the Boolean while the number of frames counts here, and then he counted how many total numbers of frames in point B. So if point A is larger or smaller than point B, it will continue for the next part. Otherwise, it will stop in this section of the workflow. That is also working, and it is beautiful for, computer science guys. If you see all this logic, you will feel that it is very exciting to see all this logic going on here, rather than, simple sampling steps going through all the images. And I don't know why people don't talk about that on YouTube or any other online tutorial in ComfyUI, that we can use the if logic and then also the loop logic to handle something within a batch of generations. Because this is really useful not only for videos, long-length videos, but you can handle like a batch of image generations. So let's say I am not connecting this math expression of the video length. Let's say I am going to have 1,000 images to generate. I can set the numbers of the counter here, and then it will be using this index to go through how many images that you need to generate within this loop. So for example, you have a flux image you generate within this logic. You can use how many counters, then pass those values. Maybe those values are your prompts, your text prompts, or from your files folder. You can set another files folder here to pass each value as the image data. Just like how I do for the value 1. Right now, I've passed it as an image list for the video combined, so it has the videos showing up here. The same concept we can use for a lot of things. It's very flexible for having the logical conditioning within the workflow, and I don't know why no one talks about that in all that process. It doesn't show that, this is AI and this is computer. This should be more into the logical way of running workflow. Yeah, so that is my thought about this, and it should be an insane upgrade of what I can do and what I will be doing in later on all my creative workflows. Trim it down, less garbage, bulky junk at the bottom of the workflow. We are able to create something with the same result, lightweight, and optimized with real computer logic here in ComfyUI. So I hope you guys get inspired on how to use the for loop and if conditions like JSN did here. Although it's very complex, I love how he can handle multiple conditions here. So I will see you guys in the next video. Have a nice day. See ya!